So now for the reason that my calculator has been sitting here the entire time. You have to have a scientific or graphing calculator in order to do trig functions. Now we're going to get into solving a triangle using trig functions. All we did before was set up the ratios. Now we're actually going to solve sides and angles of a triangle, right triangle. First thing we want to do is press the mode button on our calculator. There's two different functions you can use, radian and degree. Well, all of these that we've been dealing with are degrees of a right triangle. So you must be in you must be in degree mode. If you're not in degree mode, you won't get any of the right answers because the calculator thinks you're dealing with a trig, separate thing that we haven't done yet. So all we're going to do now is approximate the value of the sine of 82 degrees. Now, we've had many different rounding rules. When we use trig function, our rounding rules is we're using 4 digits now. So I'm going to approximate the value of sine of 82. So I press the sine function, it's right here on your calculator, and then 82, and my parentheses, and then press enter. I want the nearest 4 digits, so 0.9902. Actually, see how this 6 here is bigger than 5 next to the 2? So we're going to change that to a 3. So the sine of 82 degrees is 0.9903. All I want you to do now is tell me what the cosine of 82 is. So pause the video and see if you get what I get. We should have gotten 0.1392. The cosine button is right here underneath the program button. So we press cosine 82 and we get 0.1391, but this 7 next to the 1 is greater than 5. So we round up here. So it's 0.1392. All right, pause the video and see if you get what I get for the tangent of 82. And for the tangent of 82, we should have gotten 7.115. Remember, we want at least 4 digits when we use the trig functions. All right, now to solve a triangle using the trig ratios. First thing we have to do is find the missing angle measure if we can. So we have 90, 36, we want to find the missing angle measure B. And we can because we have 2 out of the 3 angles. So we subtract 90 from 180, and we subtract 36 from 180, and that means this missing angle is 54 degrees. Now in order to find x, we have to decide which of these angles we want to use as our reference angles. So I'm just going to say let's use angle A. If we're looking for a missing side using an angle measure and another side, we have to use the side that's already given to us, so 8. Label that side according to what 8 is in the triangle. Well, this side, 8, is the hypotenuse, so I just put a little h there. Now, since we decided to use A as our reference angle, we have to decide to find x, which side is x compared to 36. X is across from 36, so x is the opposite side. So now we have the opposite side, the hypotenuse, and our angle. So remember our trig functions, so, ca, toa. Which of these trig functions has an O and an H in it? The sine function. The sine function says the sine of an angle is equal to the angle's opposite side over the hypotenuse of the triangle. So now all we have to do is erase and replace. The sine of an angle, well, what angle do we have? We have angle A, which is 36 degrees. So the sine of 36 is equal to sine of 36 is equal to 36's opposite side. So x over the hypotenuse of the triangle, 8. Okay, so now we want to figure out what the sine of 36 is. Sine of 36 is equal to 0.587, and I'll round up to 8. And that equals x over 8. Okay, our job here is to find x, the missing side here. So we're going to cross multiply. So I'm going to put this over 1 and cross multiply. 1 times x is x equals 8 times 0.5878. 8 times 0.5878, which is 4.7024. So x equals 4.7024. Now that we have it in the form x equals, our final answer should be rounded to the nearest tenths. So x is going to equal to the nearest tenths 4.7. Okay, now let's find y. So once again, we knew this was 54. Once again, we want to decide which angle we're going to use as our reference angle, and let's go ahead and use angle B this time. Okay, so we're going to use angle B as our reference angle in order to find y. Well, we already found x is 4.7. Now, if you want to find y, you definitely have to use y in your equation. And y is opposite angle 54. So all I do is label what y is compared to 54. And then I have to label another side that I want to use. And I'm going to go ahead and use my hypotenuse again. So once again, which trig function, so ka, toa, which function has the o and the h in it? And that is my sine function. And that says the sine of an angle is equal to the opposite side over the hypotenuse. My angle, erase and replace, my angle is 54, and that equals my opposite side to 54, which is y, over my hypotenuse, which is 8. Okay, let's figure out what the sine of 54 is. Sine of 54, oops. Sine of 54 is equal to 4 digits, 0.8090, and that'll equal y over 8. Put this over 1 and cross multiply. Y times 1 is y, and that equals 0.8090 times 8, which is 6.472, but we want our answer to the nearest tenth, so 6.5. So this side y is 6.5. Now what we just did there was looking for missing side lengths of a right triangle using trig. Now, if we want to find a missing angle using trig, we're going to use what's called an inverse function. An inverse trig function looks like this. Second sine, see right here? This is called the sine inverse, the cosine inverse, the tangent inverse. And the way I remember to use the sine, cosine, or tangent function inverse when I'm using to find an angle is I look at the symbol here. What does that symbol mean? Well, that little symbol means degrees. And it's a superscript, meaning it's at the top of the variable. So every time I see a superscript, see how the -1, it's raised to the -1 power? It's up above the function. Anytime I see a superscript, it sparks my memory to think, oh, that's when I'm looking for the missing angle. I'm looking for the missing degrees of a right triangle. Okay? So once again, if you're looking for the missing angle of a right triangle, you still want to use, definitely that time, you want to use this as your reference angle. And you want to label the sides that you have in reference to that angle. We have the opposite side to x, which is 13. And we have the hypotenuse to x, which is 27. So once again, which function, I just gave it away, uses an O and an H in it, and it's the sine function. And the sine function says the sine of an angle is equal to the opposite side over the hypotenuse. Okay, let's fill in the blanks. The sine of our angle, well, this time our angle is x. That equals the opposite side, 13, over the hypotenuse, 27. So now let's approximate what 13 over 27 is. 13 divided by 27 is 4 digits, 0.4815. That equals sine of x. Well, in order to get x alone here, you can't just divide by sign, because sign doesn't represent a number. Sign of a number represents a number, but not sign alone. So in order to undo this operation, we have to raise sign to the -1 power. So we take sine of -1.4815. So in your calculator, in order to get that sine -1 power, you press second sine. See how it says sine to the -1 power? And then this number here, 0.4815. So my angle measure is 28.8 degrees. Okay, so now I'd like you to use what we applied just now to find the values of x and y. So the first step here for number 8 is to find the missing angle measure over here, h. And you should get 40 degrees. Now you decide which side or which angle you want to use as your reference angle. I want to use angle I. If I want to solve for x, I have to decide what x is in relationship to I. Well, x is across from or opposite I. And then I have to use the number that was given to us, 5. And 5 is adjacent or touching angle I. So now, of our trig functions, so, ka, toa, which of those trig functions has an O and an A in it? Well, that's the tangent function. The tangent function says the tangent of an angle is equal to the opposite side of that angle to the adjacent side of that angle. Now we just fill in the blanks. Tangent of the angle is 50, equals opposite to that angle, which is x, over adjacent to that angle, which is 5. We want to figure out what the tangent of 50 is, so tan 50 equals 1.192. That equals x over 5. Put that 1.192 over 1 and cross multiply. So x equals 5 times 1.192, which is 5.96. Now we want to find y. Okay, I'm going to use I, or 50 degrees, as my reference angle again. I'm going to use the side that was given to us, which is adjacent to angle I, and I'm going to use y because that's what I'm looking for, which is across from the right angle, so it's the hypotenuse. Now, of our trig functions, which of these has an a and an h in it? Well, the cosine function. And that says the cosine of an angle equals the adjacent side to that angle over the hypotenuse. The angle we were given is 50 degrees, so I just fill that in here. The adjacent side is equal to 5, and h is my hypotenuse, which we said the hypotenuse was y. Okay, now we want to approximate the value of cosine of 50. Cosine of 50 is equal to 0.6428. So 0.6428 equals 5 over y. We're going to put 0.6428 over 1 and cross multiply. So we get 1 times 5, which is 5, and that equals 0.6428 times y. Well, we haven't solved for y yet. We have to get y alone. So we have 6.6428 divided by y, or times y, so we're going to divide both sides by 0.6428 to get y by itself. So that goes away. So we get y equals 5 divided by 0.6428, which equals 7.7, which will round to 7.8. So x equals 5.96 and y equals 7.8. Okay, number 9 is going to be very similar to this problem right here. I'd like for you to pause the video and see if you get what I get, and I'd also like you to pause the video and see if you get what I get for number 10. Okay, so for number 9 you should have gotten 52 degrees, and number 10 you should have gotten x is 7.7 and y is 2.6.